But right now, NASA is searching for thousands of worlds beyond Earth. Every night when we look at the sky, it feels familiar. The stars appear fixed. The constellations seem permanent. And for most of human history, we believed the universe contained only a handful of known worlds. But that assumption was wrong. Beyond our solar system, countless planets orbit distant stars. Some are larger than Jupiter, some are smaller than Earth, and some may exist in places where liquid water could survive. The problem is that these worlds are incredibly difficult to see. Most are hidden by the overwhelming brightness of their parent stars. Even the largest telescopes often cannot observe them directly. So NASA built a spacecraft with a different mission. Its name is TESS, the Transiting Exoplanet Survey Satellite. Instead of looking for planets directly, TESS watches stars, thousands of them, millions of them, patiently measuring tiny changes in brightness that occur when a planet passes in front of its star. Those changes are incredibly small. In some cases, the dimming is less than 1%. Yet from those tiny signals, entire worlds can be discovered. Since its launch in 2018, TESS has transformed humanity's search for planets beyond Earth. It has surveyed nearly the entire sky and identified thousands of possible worlds waiting to be confirmed. Some may be scorching infernos, some may be frozen wastelands, and a few may resemble Earth more than we ever imagined. But finding planets is only the beginning. Because the real question is not how many worlds exist. The real question is whether any of them could be places where life might survive. And that is where the story becomes far more interesting. Finding a planet around another star sounds impossible. After all, stars are enormous. Planets are tiny by comparison. Trying to observe an exoplanet directly is often like searching for a firefly beside a giant spotlight from thousands of kilometers away. So TESS uses a clever method. Instead of looking for planets, it looks for shadows. As a planet crosses the face of its star, it blocks a tiny fraction of the star's light. For a brief moment, the star becomes slightly dimmer. Then the brightness returns to normal. If the same pattern repeats again and again, astronomers know something is orbiting that star. The timing of those transits reveals the planet's orbital period. The amount of dimming helps estimate its size. And when combined with observations from other telescopes, scientists can begin to understand the nature of an entirely new world. This method has become one of the most successful tools in modern astronomy. TESS constantly records enormous amounts of data, monitoring vast regions of the sky at once. The spacecraft does not focus on a single star. Instead, it scans entire sectors of the sky, gradually building one of the largest planetary surveys ever attempted. Every observation increases the possibility of discovery. A rocky planet, a giant gas world, an ocean-covered planet, or perhaps something humanity has never encountered before. And as the number of discoveries grew, a surprising pattern began to emerge. The universe appeared to be filled with planets, far more planets than many scientists expected, which raises a remarkable possibility. If planets are everywhere, could Earth be less unique than we once believed? For centuries, humanity knew only the planets of our own solar system: Mercury, Venus, Earth, Mars, and the giant worlds beyond. That was our entire planetary inventory. Today, that picture has changed completely. Thousands of exoplanets have now been confirmed, and TESS has become one of the most important contributors to that growing catalogue. Many of these worlds are unlike anything found around our Sun. There are planets larger than Jupiter, orbiting dangerously close to their stars. There are worlds where temperatures could melt metal. Others may experience permanent darkness on one side and eternal daylight on the other. Some orbit two stars at once. Others circle small red dwarf stars that dominate our galaxy. The sheer diversity is astonishing. Every new discovery challenges assumptions about how planetary systems form and evolve. And perhaps the most important realization is this: our solar system is not the standard model of the universe. It is simply one example among countless possibilities. TESS continues to expand that picture. Its observations have revealed systems with multiple planets, compact planetary families, and candidates that may eventually become some of the most important targets for future study. The more worlds we find, the more complex the universe appears. But among all these discoveries, one category attracts more attention than any other: worlds that resemble Earth. Not because they guarantee life, but because they remind us of home. And those worlds have become one of the primary reasons humanity continues searching the stars. The dream is simple: find another world where life could exist. Not necessarily intelligent life, not advanced civilizations, just a planet with the conditions needed for biology to begin. That search drives many of the most ambitious missions in modern astronomy, and TESS plays a crucial role in that effort. The spacecraft has identified numerous candidates that orbit within what scientists call the habitable zone. This is the region around a star where temperatures may allow liquid water to exist on a planet's surface. Water alone does not guarantee life, but on Earth, every known living organism depends on it. That makes water one of the most important clues in the search for habitability. Some TESS discoveries appear rocky, some may possess atmospheres, others orbit stars smaller and cooler than our Sun. Each candidate becomes a target for more powerful observatories, including the James Webb Space Telescope. TESS finds the worlds. Other telescopes investigate them. Together, they form a planetary discovery network stretching across space. And with every new observation, the possibility remains the same. One of these distant planets may eventually reveal evidence that life exists beyond Earth. Not tomorrow, perhaps not even soon. But for the first time in history, humanity is actively searching for answers. And the universe is providing more targets than we ever imagined. Yet there is another discovery hidden within TESS's success. A discovery that may be even more profound than finding another Earth. One of the most important lessons from TESS is not about a specific planet. It is about scale. Before exoplanet missions, many scientists assumed planetary systems might be relatively uncommon. Now the evidence points in the opposite direction. Planets appear to be everywhere, around large stars, around small stars, around young stars, around ancient stars. In every direction TESS looks, new planetary candidates continue to appear. The Milky Way alone contains hundreds of billions of stars. If even a fraction of them host planets, the total number of worlds becomes almost impossible to imagine. Some estimates suggest there may be more planets than stars in our galaxy. That realization changes humanity's place in the universe. For generations, Earth felt unique. Now it may be one of countless planetary stories unfolding across the cosmos. Most of those worlds will remain unreachable for centuries. Many may never be visited, yet they exist, silent, distant. Orbiting stars we can barely see. And every time TESS discovers another one, the universe becomes larger than it was before. Not physically larger, but conceptually larger. Our understanding expands, our assumptions evolve, and our curiosity grows stronger. Because once you realize the sky is filled with worlds, a new question naturally follows. If planets are everywhere, what else might be waiting among them? Right now, somewhere above Earth, TESS continues its mission, quietly observing the sky, watching stars flicker, recording shadows, searching for worlds hidden within the darkness. Its discoveries have already transformed astronomy. Thousands of planetary candidates, thousands of possibilities, thousands of reminders that our solar system is only a small part of a much larger cosmic landscape. And yet, this may only be the beginning. Future observatories will examine many of the worlds TESS has discovered in far greater detail. Scientists will search for atmospheres, clouds, oceans, and perhaps signs of biological activity. The answers may take years, perhaps decades, but the search has already changed humanity forever. For the first time, we know with confidence that planets are not rare. The universe is filled with them. Some may be frozen, some may be covered by endless oceans, some may resemble Earth, and some may be unlike anything we have ever imagined. Every discovery raises new questions, every answer reveals new mysteries, and somewhere among those thousands of worlds, there may be places waiting to redefine everything we know about life and our place in the cosmos. If you enjoyed this journey beyond our solar system, There are many more mysteries waiting here on the channel, from impossible galaxies discovered by James Webb, to hidden worlds, distant moons, and strange planets lost in darkness. Because the deeper we explore the universe, the more extraordinary it becomes.